Hello everyone, this is Rishida. Welcome to my channel. My today's video is going to be on activation functions. Activation functions are very important for deep learning. I discussed about activation functions in my video on neural networks, and in my last two videos on TensorFlow model development, I used activation functions in every layer. So I decided to make this video on activation functions so that when you make your model, you have better idea on which activation functions to use for your model. So these are some most commonly used activation functions. Rectified linear activation, ReLU, and there are more activation functions that came out of ReLU activation function. We will talk about some of them as well. Logistic or sigmoid activation function and hyperbolic tangent or tanh. So first, sigmoid activation function. This is also called logistic function. This function used in the logistic regression. And sigmoid function takes any real value as input and returns a value in the range of 0 to 1. And this is the formula 1 over 1 plus e to the power negative x, and it usually gives you this S shape. The next one is tanh, the hyperbolic tangent activation function. And this has the similar shape as sigmoid activation function. You can see that it also has this S shape. Difference is it has a range from -1 to +1. And here is the formula e to the power x minus e to the power negative x divided by e to the power x plus e to the power negative x. This is very popular activation function for hidden layers. ReLU, probably the most common functions and most popular functions used in hidden layers. The reason it's very popular is it's very simple and effective at the same time. This is the formula max 0x. So what it does, you probably can guess just by looking at this formula that if you pass a negative x or negative value here, it will return 0. Otherwise, it will return x itself. And this is the shape of this one. You can see that left side of y is always 0. So after value activation function, you can never get a negative value. It's always 0 or some positive values. The issue with the value activation function is it can get trapped in a dead state because in this side, in the right side, is always 0. It can deactivate the neurons in this region. So the learning of a neural network can get slow because some of the neurons get deactivated. So this is called dying ReLU. So leaky ReLU activation function solves that problem. What leaky ReLU does, you can see this is the formula. When x is negative, it multiplies it with a very small number, such as 0.01. And when it's positive, it just stays as it is. When you use leaky ReLU, the left side of y-axis doesn't stay 0. It becomes something like this, the shape of the graph. The negative value becomes small, but not totally 0. So those neurons don't die. They're still activated. The exponential linear unit or LU activation function also based on ReLU activation function. You can see that what this one does, when x is negative, it takes the exponential e to the power x minus 1, and then it multiplies with 0.01 or such a small values. So what it does, it smooths out the curve here. In leaky ReLU, this side is sharply drops. And in LU, it has some kind of smooth curve, and then it evens out like that. So LU also can produce negative value. Again, the negative values become smaller, but it still stays. Another one is SELU. In SELU or scale exponential linear unit, you can see there is a value lambda and alpha multiplies with e to the power x when it's negative. And this lambda gets multiplied if x is positive as well. And in the original paper, the value of lambda is 1.0507 and the value of alpha was 1.6733. And you can see the curve. Here, the curve becomes a little bit more round shape. SERU activation function is supposed to converge faster. So in your hidden layer, you have multiple different kinds of activation function to try with. Now let's see the activation functions for output layers. So there are multiple different kind. One is linear, then logistic or sigmoid, softmax, and sometimes I use ReLU as well. For regression, it is common to use a linear activation function. The linear activation function can just return the x itself or this linear formula ax plus c. If you have watched my last video on regression model development in TensorFlow, Keras, and Python, I used a value activation function in my output layer. The simple reason is target variable was housing price. So you know that housing price is not supposed to be negative, and the simple value activation function simply makes it zero when there is a negative value, and it keeps the positive as it is. So I thought I can use value activation function safely here. For classification problems, sigmoid function is very commonly used in the output layer. We already talked about it in the beginning, but it is actually good for output layers in the classification problems. You can use sigmoid activation function in the hidden layer, but it is very commonly used in the output layers of classification problems because it returns a value ranging between 0 and 1. It is good for binary classification. It can be used for multi-class classification as well, but not recommended. For multi-class classification problem, the most commonly used activation function in the output layer is softmax function. It returns a vector of values that sum to 1, which is probabilities of class membership, and this is the formula, Ex over sum of e to the power x. Well, that's all I wanted to share with you guys today. I wanted to discuss some options for activation functions with you so that you can make good decision when you use activation function in your models. There are lots of other activation functions. You can define your own functions, custom functions as well. In some future videos, I will show how you can do that. Please stay tuned. If you like this video, please like, comment, share, and subscribe. Thank you so much for watching.